Hi, I want to go over molecular orbital pictures with alkanes, alkenes, and alkynes. So here's my model of an alkane. I have ethane specifically with 2 carbons and 6 hydrogens. Carbon-carbon single bond. The carbon is sp3 hybridized. sp2,3. And an alkene is a carbon-carbon double bond. This specifically is ethene. I have a carbon-carbon double bond and it has 2 hydrogens. It's sp2 hybridized. And Ethine. Again, 2 carbons. When we talk about hybridization, keep in mind that multiple bonds count as 1. So the hybridization around this carbon here is sp. And we're going to talk about the molecular orbital pictures for these. We're going to start off with ethane. Here's a molecular orbital picture of ethane. Here's my model. And this is its orbital. What we notice is all these pairs of electrons want to be as far away from each other as possible, and that's where the tetrahedral shape comes in. This is just a carbon with its 1 electron, and the same thing is actually happening here, but notice I have a second carbon over here. So the electron lobe is actually this dumbbell shape, but when they share together, right here we get a sigma bond. There's 2 electrons showing a sigma bond. So this model is showing you just the electrons involved in the carbon, and on a molecular orbital picture we're going to be including how the hydrogens attach onto here. So that's what's missing from this particular model. Let's look at ethene. Here's its model, carbon-carbon double bonded. Here's the model of its orbital. What I'm holding right here is the sigma bond. We have a carbon-carbon bond, the first bond that holds any 2 atoms together. That's going to be our sigma bond here. What I also have is the pi bond above and below. So take a look at this. I have the pi bond is this square region here. That is 1 bond. Even though it goes above and below the plane of my carbon-carbon bond, this is the second bond. So we have, with ethene, we have a sigma bond and 1 pi bond. Now here's the molecular orbital for ethene. Here's my model. All right, let's take a look at this. What I have going is, it's kind of hard to see, I'm holding on to the sigma bond. I have a carbon-carbon single bond. And just as we did in the alkene, I have the pi bond above and below the plane, but I have another pi bond coming out. And let me tilt this a little bit so you can see this. So there's only 3 bonds going on, even though all this action is happening. So the first bond is a sigma. There's a pi bond here and a second pi here, and that's how it is a triple bond. So let me show you how to draw it. For the molecular orbital picture, what we need to do is we need to show that carbon has its electron, and the second carbon has its electron, and they're sharing the pair of electrons, and this first bond here is the sigma bond. Because we have 3 hydrogens on each side, carbon always has 4 bonds. I'm going to go ahead and represent the bonds to hydrogen. Remember, each hydrogen brings in 1 electron for the bond, and each carbon brings in 1 electron. So inside of each of these overlaps, I'm going to be placing an electron. The first bond that always puts together any 2 atoms is always called a sigma bond. So I'm going to go ahead and label those sigma. I'm going to do the same thing to the other side. And these particular shapes, they're supposed to look kind of like those dumbbell lobes, but if you go ahead and just kind of do a ring shape, do the best you can, that would be fine. So this is didn't label. Carbon hydrogen is a sigma bond, sigma bond, sigma bond. So this is how you would represent the molecular orbital picture for an alkane, and this is specifically the molecular orbital picture for ethane, showing all 6 hydrogens. For an alkene, we need to keep in mind we still have carbon bonded to another carbon. That's going to be represented with a sigma bond. And in this case, I have just 2 more hydrogens to show on each carbon. And because we know that this is sp2 hybridized, we want to maintain the bond angle at that 120-degree bond angle we're used to. So we're going to go ahead and show it that way. And this carbon also has his 2 hydrogens. labeling all these bonds. Remember, the first bond any two atoms always make are sigma. So the next thing we're going to do is we're going to put in our pi bond. And I'm going to go ahead and show you this with a different color. If you keep in mind, what we're looking at here is I've drawn the sigma bonds between carbon and carbon. I've done the hydrogen bonds. Remember, this model doesn't show the rest, the hydrogen part coming off of it. And now I'm going to draw this pi bond here. So let me go ahead and show you how to do that. We're going to go ahead and put a lobe above and below the carbon. I really can't see that well. Let's see if I used another color, if we could see that better. Let's go ahead and change up the color there. That's better. All right, so I'm going to put a lobe above and below the carbon here. That's half of it. This is the other half, and I have to connect them. So make sure you connect them. And this whole part that I have here in this kind of red color, looks more pink to me, this red color here, this one piece, the square piece, is a single pi bond. I'm going to go ahead and label that. For the alkyne, and this is specifically ethine, I have a carbon-carbon triple bond with its two hydrogens. So what's going to happen is carbon is going to bond to the other carbon. The very first bond that is always made is a sigma bond. And then remember, I only have a single hydrogen from each side, and we know that this carbon here is sp hybridized, so it's going to be linear, so let's draw it linear. This would be a sigma bond from carbon to hydrogen and another sigma bond from carbon to hydrogen. So what we're going to do, like we did in the alkene, is we're going to go ahead and show that pi orbital above and below the plane. And, oh, something I forgot to do on the other one. I forgot to put my pair of electrons in there. You can put the pair of electrons anywhere in that region there. So I'm actually going to come back over here and put in a pair of electrons right there. Sorry about missing that. Did you guys see that? You need to make sure that this pi orbital has a pair of electrons. And it doesn't matter what lobe you put them in. If you noticed over here, I went ahead and put them in this lobe. So this is now carbon-carbon with the sigma bond. It now has its first pi bond. And now I need to put in its second pi bond. With the second pi bond, remember, it's coming out at me. Let me show you the model. So we have the the carbon-carbon sigma bond. We have the first pi bond that's going up and down. Now I need to illustrate this bond that's going back and forth. So on my model, I'm basically going to, on my diagram, just like I'm doing with my model, I'm just going to tilt it just a little bit. So I'll show you how that works. I'm going to go ahead and draw this lobe coming out here, and the lobe going back, this lobe coming out, and this lobe going back. And then I'm going to connect them. And since this is in the front, when I connect them, I'm going to go ahead and write in front of everything. And because this one's behind, I need to, when I actually connect these, go behind this piece here. And remember, it has a pair of electrons. I'll go ahead and put them here, and I'm going to label this as my pi bond.